Hi, so we're going to do the PAT paper in 2016 looking at question 13. Question 13 says, for temperatures ranging from room temperature and above, sketch how resistance varies with temperature for A, an ideal wire, B, a filament bulb, and C, a thermistor. So let's start with A. Now this is a bit of a trick question, because what they've said is that the wire is actually ideal. And what do we know about ideal wires? Well, an ideal wire carries current perfectly, and so will actually have no resistance. So what this will be is simply a straight line along the x-axis with the corresponding to a resistance of 0 for all temperatures. It's an ideal wire. Okay, what about B? Well, B wants you to sketch it for a filament bulb, but we're starting for temperatures around room temperatures. We'll call that T sub R, and then we're having T increase and R. So what happens? Well, we know for a perfect current, like a perfect ohmic material, that resistance and temperature increase linearly. However, for a filament bulb, we know that things in real life aren't actually ohmic. So what we're going to have it increasing and then exponentially increasing as temperature rises. It's not going to be a linear relationship. But we're starting at room temperature. It's not going to start with zero resistance. So we're going to start somewhere here, and then it's going to be non-ohmic and increase like an exponential. So it'll be something like this. And what about C? Well, a thermistor is by definition a device that loses resistance with temperature. It's a semiconductor. So that means is as temperature increases, the electrons become more, it dislodges more electrons, and so more current flows, and so the resistance actually falls. So what this means is we start, because it's a room temperature, it's not going to start at infinity, it's going to start at some value of R. And then it's going to come down in the opposite way as a filament bulb and tend towards 0 as T tends to infinity. And those are going to be our graphs.